Sort of to frame today's interview, metabolic testing is definitely exploding in popularity. There's a lot of interest. We've got innovative tech like VO2 Master that's making portable metabolic testing possible. So it's making it a lot more accessible. And that brings me to you as an expert in this field and so much experience. I believe you've been using VO2 Master for 8+ years. Is that right?
Something like that, yes.
I'd love to understand, first of all, why you're using VO2 Master. Then we can get into kind of how you're using it to optimize the protocols for your athletes and how other coaches can do the same. So starting on kind of a high level or broader question, how did you decide to use VO2 Master compared to other tools on the market?
For me, I have a first principle approach. The question really is, okay, how can we work in a way that we can increase the accuracy of what we do? And we can say a little bit bluntly that we are also not academics. We are, let's say, mixture between, let's say, coaches and applied scientists in a way that we need some reliable metrics that allows us to understand from basically input to output what is really happening. Output is obviously how fast you go from A to B in a race, for example, or on a training session. The input is basically how much energy are you actually ultimately using or expending on it. Obviously, measuring energy is also something that is inherently complicated. And that's why we use oxygen as a proxy to understand it. Because in the end, whether we talk anaerobic, whether we talk aerobic and so on, you can actually quantify all of that even with oxygen. Because if you do something anaerobic, you cannot, at the moment you stop doing it, the body is seeking to come back into homeostasis, and oxygen is actually also a reflection of that process of bringing you back to homeostasis. So this means that if we, to use a metaphor or an analogy, you can almost think of this as like a race car. And on a race car, what matters in the end is how fast you go around on the track from A to B, or basically cover X laps in certain time, the faster than your competitors. Not one lap, but basically all the laps that is required to win. On the input side, we can say that there we want to know how much fuel your car is using. So of course, there's practical way of measuring the fuel because you know how many liters of fuel you actually put into the tank. And that's the equivalent of indirect calorimetry, or basically the VO2 Master, where you basically then quantify the energy input and you have the velocity output. Power, really, which very often is used as a proxy to understand whether you get fitter, is actually just an efficiency metric, because it sits as like an interface between the input, which is the oxygen input, and how effectively are we able to convert that energy or that oxygen into work. But of course, there's another step as well, and that is that you can still, let's say, expend that work very ineffectively by on a bike sitting very straight upward, and you have to push a lot of power to go for a certain speed, or you can get lower, more aerodynamic, and you can go faster. Or for a runner, for example, if you don't run, if you have a poor running technique, you will expend more energy, let's say, traveling from to a little bit larger extent than cycling, but a little bit more energy to then travel from A to B. So you can think of it, if you run like in a zigzag line, that's for between A and B, that's very ineffective compared to if you run more in a straight line between A and B. Simplified. So again, for me, using the VO2 Master and having access to GPS, power meter, and so on, allows us to actually think of it more from an effect standpoint. Ultimately, what we are after is effect. And then you can say that, well, a race is a reflection of how good you really have been training. And that is actually yes and no. Because a race is also affected by many other factors than just purely your physiology or your performance. And that's where, again, the tools gives us a far more accurate picture of actually where is the adaptation going. Say that the three most important tools we have are, on the one side, obviously the GPS or GNSS system that captures the time from A to B and the distance. The second one is the power meter, because it allows us to measure how much work you're doing to travel between them, and ultimately how much energy is actually required into the system to be able to travel over that distance or do that work. Those are the three key tools, and those we basically use to assess when we build a block training program, whatever. We track how is that influencing these three main parameters in the program, or let's say in the response of an athlete to a program.
What are some of the kind of key metabolic tests we can use to create that kind of metabolic or power profile for an athlete? I think a lot of people will be familiar with the VO2 max test, which we can talk about, but there are more metabolic tests possible. And are there some key ones, or is there a go-to one that you would use with an individual?
Yes and no. If I've never been with an athlete before, there are two ways I would approach. Of course, one is the standardized way, just to have a comparative, let's say, starting point. So let's say a graded exercise test.
Yes, already there's nuance, right? Because are we trying to get maximal metrics here with a short step test, or are we trying to get more insight in the physiology with a longer step test to see, ventilatory thresholds, etc.?
You could say that VO2 max in itself, of course, on the one side is hailed almost like a holy grail metric because it encompasses so much into one single metric. And it's fairly easy to quantify without even having a record of your training in past year, because you can deduce quite a lot from that metric. However, I would say that it's still a single metric that doesn't detail or give a lot of insight into who you are, except from, okay, obviously you must be fit or you are unfit or whatever. So it places you somewhere in that category. But what is inherently more difficult is to understand, where do I now prioritize moving forward for this athlete? For that, then you need more data. I would still say that maybe a very simple way to start off the first time, I would not necessarily recommend this as you start to move on, because then there are far more practical and better ways to do this. But let's say as a starting point, or let's say somebody you don't work very often, then, for example, I would normally have a step test before, and you need to capture oxygen at each of these steps as well. That is actually quite critical, I would say, for the information. The reason for this is because very often we talk about thresholds, we talk about different other factors that are there as well, but all of these are actually a balance between the glycolytic system or the anaerobic system and the aerobic system. That is basically what controls as a where your threshold sits. However, we can get a very detailed understanding, or the most accurate way to basically quantify, and let's say I would almost argue the most reliable and accurate way we can capture the balance between the aerobic and anaerobic system is by, for example, doing a step test with oxygen captured simultaneously on each of the steps. The reason for that is because this allows us to then say that, okay, let's say that you define a threshold, for example, for this athlete. And there are many ways to do this. Of course, I would normally say that I would try to do this either by doing VO2 steady state, but even more, maybe ideally, maximum lactate steady state for an athlete. When you do that and you find that inflection point for an athlete and you have oxygen uptake at that intensity, you can take that oxygen uptake now and compare that to the oxygen uptake at max. And that gives you a utilization. So, for example, if that utilization is for a marathoner, you would expect it to sit above 90%. And then you know that, okay, this is starting to become a really good marathoner. The best ones are even closer to 95%. Incredibly high utilization. However, the interesting part there is you see that they don't have a very high VO2 max, because it is not a very crucial metric for them. Or let's say it's not the most important. It is a crucial metric, but it's not the most important metric for them to be fast. Maybe bring in a little bit more nuance to that, and that is that VT2, or ventilatory threshold 2, or maybe even better, I would say VO2 steady state, sits above maximum lactate steady state. So they are close, but they are not the same. Well, it sits above. The reason for why this is important is because it would immediately inform us whether we want to do more extensive sessions, more volume, or whether we want to intensify and focus more on the higher power for that athlete, depending on where it is. And that means that, for example, for a track cyclist, if you see that he sits around 95%, I can tell you he's not able to go very fast. They will, you typically see, sit closer, actually more to 75% in terms of utilization. So say that the threshold value that sits very low compared to their VO2 max, simply because let's say the threshold is a balance between the anaerobic and aerobic system. The highest measurements we have gotten with Christian, Gustav, Kasper, and so on Solvay, for that sake, also winning now Ironman Kona this weekend, is actually long tests. So fatigue, the longest test we've done, this is actually where we also have gotten the highest VO2 max for them. But again, scale to the individual.
Traditionally, I thought that the VO2 max test and the longer step test to kind of help build a bit of a metabolic profile for an athlete have to be two very separate tests performed on two very separate days. Are you saying that you could technically consolidate all that down to one test, get a really good understanding of low through to high intensity and capture VO2 max all in one? That's interesting. And again, in terms of the length of those steps, that's going to depend on the athlete because it has to be calibrated to them.
Yes, exactly. Or let's say the intensity of the steps, not the duration, because the duration I would recommend, even for years, practicing this and really, let's say, perfecting the skill. I would even say just standardize around 6-minute steps and ensure that you start low enough and you end up where the last step is then, let's say, where you get a good jump in your lactic concentration, to put it that way, and where typical an athlete would report on a scale from 0 to 10 in terms of, let's say, perceived effort or let's say perceived fatigue, they should be at, let's say, at an 8-9 at the last step. So if they report 8-9 and you still have a low value, you can try to push one more, but then that might actually end up being your VO2 max instead of a graded exercise test afterwards. But that you will obviously see very quickly afterwards.
That's really interesting. I'm excited to try that. I've done traditional short step tests for VO2 max and longer step tests. You're going to start at an intensity, I think the general guideline is below 100 beats a minute, or maybe a 3 RPE or something for that first. You kind of want to work through the RPE values up to an 8 or 9. That's going to be a fairly long test, but you're going to capture a lot of great data to get stuck into from that.
Exactly. And I would also even argue that consider this not necessarily a test, but equally much a really good training session. It's a progressive, good training session with an all-out effort at the end of it, even competitive specific, you could say. And that means also that I would also recommend that the athlete has a good warm-up before, even like 15, 20-minute warm-up before. But what is important at the warm-up, I would say, to avoid complicating the measurements, that the intensity during the warm-up, you should have a little bit of, let's say, steps there as well, but make sure that you cap them at a fairly low lactate value so that they don't get too high, because otherwise you will drag a high lactate value into the beginning of the test. If you're skilled, you'll be able to deal with this with no problem. However, for new people, this will become like, why is the lactate coming down now? What's happening here? And it becomes a little bit more complicated to see past, to put it that way.
Can we now talk about the metrics that are captured with VO2 Master? Because I know when I got my hands on one, I was all excited about VO2 max. And then I was like, oh, what's all this great data under the curve? And then got really excited about tidal volume relative to respiratory frequency and minute ventilation. And it's in that data that really improves my own metrics and the clients I work with. So can we list some of those key metrics that it's capturing that you're looking at and how you're using that to inform protocols?
So of the metrics that are readily available on the screen, I would say there are 3 key metrics that we look at. And the 3 key metrics, you already talked about one of them, tidal volume. The other one you also mentioned, and that is breathing frequency. And the third one is basically the fractional or fraction of expired O2. Why? Because those are the 3 raw metrics. VO2 is what maybe people actually don't know, is that none of the metabolic cards we have, whether they cost 5,000 or 50,000, actually measures raw oxygen uptake. They calculate it from those 3 metrics. The reason for why you need breathing frequency and tidal volume is because those 2 combined gives you minute volume, as you mentioned, your ventilation. That is basically because we know that in the air is 20.9% oxygen. So then we can already say, well, if it's 100 liter, if basically the tidal volume multiplied with the breathing frequency adds up to being, for example, 100 liters per minute, it means that in those 100 liters per minute that you're breathing, there are 20.9 liters of oxygen that are being, let's say, drawn into your lungs. However, you are not able to extract all that oxygen that comes into your lungs because the contact time is too short. If you hold your breath, if you inhale, you will be able to extract more of that oxygen that is available there. But that's not very efficient for you when you are exercising and you need to breathe to make sure that you really have a good, let's say, good exposure for oxygen to your lungs. And that brings, of course, in where we will touch into just briefly probably, what happens if your breathing frequency goes too high and let's say, you get too short contact time for oxygen in your lungs. What tells you how much you're extracting is the fraction of expired O2, which is a concentration metric. So typically, if you basically hadn't used any of the oxygen, then you would basically see that it sits between, let's say, 16 to 19%. That's where it normally sits. And one thing that people also get a little bit confused about, maybe in the beginning when looking at this, is that this value, or let's say the value is the lowest actually around your first ventilatory threshold. Then as you pass by, and before that point, you will see there's a little bit higher, and then it gets lower, it gets lower, it gets lower. Eventually, as you pass your first ventilatory threshold, it will start to increase again, fairly controlled up until you pass the secondary ventilatory threshold, where it starts to rise much more rapidly afterwards. This has to do, of course, with one of them being contact time. Like how long time do you actually also your lungs have the ability to extract the oxygen from that? However, the reason for why VO2 increases still, even though the extractability of oxygen goes down as you increase intensity, is because the volume of air that you're inspiring increases faster than, let's say, the reduction in extractability is reduced as you go with higher intensity. So those are the three most important metrics that you have available. And then, of course, it simplifies it to have a quick look at when you also have VO2 obviously available, because that's what you really are there to measure. And then, of course, the ventilation gives you also a little bit of idea, okay, where are we now in terms of, let's say, how much volume is it we are actually inhaling for that. But the three metrics there, those are the most important metrics for me that informs me a little bit about, let's say, efficiency, inefficiencies in their breathing, for example. Also, when you're changing position on a bike, what's happening with these three metrics when you change the position on the bike? Some of them will be influenced by your seat height. Some of them will be influenced by, let's say, whether you go more aerodynamic, less aerodynamic, because it has to do with restriction of your diaphragm. And your body needs energy. It needs oxygen. So the body will try to compensate for this by, let's say, by forcing a change in some of these metrics. So, for example, if your ventilation goes down for the same power output you are doing, what you'll see is that extraction will start also to go down. Well, actually, extraction increases, but that is manifesting itself by that FeO2 percentage goes down because you need to extract more for it. So we have to remember the body is a highly adaptable that will adapt to whatever you expose it for. But the question is a little bit how it does it. And unfortunately, it's not like bringing up your breathing frequency. Put it this way, breathing frequency and tidal volume is a little bit like cadence, let's say, or cadence or torque. Or you could say, for example, in running, stride length versus stride rate. We know that you can run 10 kilometers per hour, 20 kilometers per hour, but you can do it in multiple ways when it comes to combinations of stride length and stride rate. And it's not very efficient to run with an extremely high stride rate and very short stride lengths. So it's a sweet spot, as we understand, between stride rate. And the same thing also goes with breathing. There's a sweet spot where you will be able to extract the most oxygen for the intensity in the combination between breathing frequency and tidal volume. Fraction of expired O2, that's an autonomous function. That is something the body will regulate, and you will see there are kinetics involved into it. It's not like if you hold your breath that instantaneously this would change, but it will change, let's say, curve line linearly. And the same way the other way around. If you start then to breathe more again, you will see the opposite. And this is, of course, a hot potato in some of these environments. Well, that's not true. Then you're not really capturing your O2. Yes, you are. You are really capturing your O2, but I wouldn't call it VO2 max because you teach an athlete to hold their breath at a high intensity for a half a minute, and then they basically hyperventilate afterwards to really spike their O2 at very high because of lag in the body, or let's say lag in different systems, or let's say kinetics in the body. So it's a true measurement of a very high oxygen uptake, but it's not your VO2 max. is basically an inflated value because you manipulate your body, and the body has to repay the debt that you have accumulated, and you'll get, yeah. So if you average it over a longer period, then you'll get back to where you see, well, it's still the same. However, why there's a sweet spot is because a very high breathing frequency has a cost to your lungs.
Right.
The same thing also going over expanding your lungs to bring in air, for example, also has a cost because you are using muscles. It's easy to think that it's only our legs that are doing muscles, but we have to remember that our heart is doing work, our lungs are doing works, our diaphragm, or stomach, all these systems in our body is doing work. Part of the equation is a part of the efficiency.
Yeah, from what I understand, there's dead spaces in the lungs, right? So if you've got a high breathing frequency and a relatively low tidal volume or amount of air going in and out of each breath, there's a certain portion of that air at the top of the lungs or in the trachea that's not participating in gas exchange. And so we kind of probably want to more optimize for depth of breath versus frequency. It's kind of how I have learned to do it, is to really prioritize depth of breath, the higher tidal volumes, and then as intensity increases, increase the breathing frequency without losing too much tidal volume.
I would say that there are a couple of ways, or let's say a couple of different environments and different approaches to this. One of the things we let's say throughout the decades, we of course have played around with everything from spiral tigers to power breathe and other things to do something with the lungs and other. However, where we are today is that we basically see that this is rather a function of training and let's say training, biofeedback, and awareness. We don't do any kind of artificial breathing or other things like this. It's more about bringing it to the attention of the athlete and then measuring it regularly so they can actually connect their own feelings to a metric and say, okay, so when I do this and it feels like this is actually what is happening there, bring that back out again. And that's the beauty, of course, with the VO2 Master, which is in the beginning, but with the VO2 Master compared to, for example, other metabolic analysis. And that is that, and especially CAS, is that we can do this out in the field with the athlete on different intervals, different sessions, every week, over weeks, over months, over years, and capture, because you ask, how can we build also a metabolic profile? And the way actually we do it is in the same way you can actually build a velocity profile of an athlete or a speed profile of an athlete by just looking, okay, how fast are you able to run over 100 meters or 1 kilometers and so on? What are your all efforts there? Or let's say your repeated efforts over there. In the same way, we can build power duration curves optimized today with power meters, and you build then power curves, but we won't be able to do that in the same way with metabolic analyzer, but VO2 Master is the place where we can get to the closest to it, because it allows us to capture on an interval in the beginning, in the mid, at the end as we want, because it's so quick. And that means also that when I'm out with my athletes and we are testing, or let's say doing training, and we're using it in the training area, you want them to do what I do normally in training and racing. It's so little that I can bring it on, let's say, during the warm-up a little bit, calibrate it, and then afterwards, when we do measurement with it on interval number 2 and 3, 10, for example. And that allows also to connect it actually with fatigue as well. Like, what does oxygen uptake look like at a certain power output or a certain speed or velocity in let's say, after you run only 2K, after you run 10K, or whether you run 20K, for example, which again also increases my understanding not only of a simple profile that you do in a lab that is harder to transfer to the field, but actually where we do all of this out. So that's why also in the beginning I said, yes, it's good to start with a graded exercise test and a step test, or step test and a graded exercise test in the beginning with a client or somebody. But from there on, I would just stick to the field and go to the lab only if there's something very, very specific I want to do.
I think one of the best values I get out of the tool is well, after doing the step test, is wear it during training. And even something as simple as a zone 2 session on a bike or running, people don't tend to have awareness of how deep they're breathing, how many breaths per minute. Those metrics are typically quite all over the place. There's no regular pattern. And you can see that right there in the data. You can then wear it during training and coach breathing and see it live. tidal volume and respiratory frequency. Like I know for when I do my zone 2 work, it's 3 liters per breath and it's 17 breaths per minute. Like that level of accuracy you can get with all your different types of training. You can see when that drops off, etc. And you can play with different combinations, I guess, of tidal volume relative to breathing frequency and see the impact it has in terms of power output, etc. and efficiency.
Exactly. Also to exactly that point there as well. When you're out running then and you're going higher intensity, because at the lower intensities, of course, you have more room, you have more, let's say, you have more resources free for your cognitive abilities. The higher you go at intensity, less resources will be available for perception or the cognitive system. And that means also in those cases, being able to evaluate or assess how is my breathing frequency now might not happen unless somebody brings it to your awareness. Either somebody's saying, hey, how's your breathing frequency? And then you bring your attention to it. However, you don't know, is it good? Is it bad? And when you really have biofeedback with a VO2 on your face, and you start to know that when I've been in my lab and I've been playing around at a certain intensity, sometimes with lower breathing frequencies, sometimes with higher breathing frequencies over many sessions, you know that this is a spot where I know I'm actually very efficient. And for some athletes, this falls more naturally. They have other limiters. For some athletes, this is a limiter. And that's why having a tool like this allows you to assess together with, for example, power and velocity, where is it my focus have to be with this athlete. Take a look at the Tour de France this year, and you look a little bit on some of the best riders there, and it becomes quite evident that amongst the top 3, there is one of the guys that is quite focused on his breathing. It's not a secret, but even in the elite environments, this is very often forgotten. If you look at Christian, if in some videos, I think there are not many of it, but I think there are a few, you'll see very clearly that when he starts running, he has a very distinct way of breathing in the beginning of the intervals. And this is something that I think even he did before I started working with, because naturally that it was natural for him to do that. However, for other athletes, you need to increase the awareness around this. For example, hey, what's your breathing frequency here now? See if you can slow it down a little bit.
That's inefficient too, because it's costing energy, right? It's, as you say, it goes back to what's the sweet spot, and you're only going to know that by measuring it and looking that against the output that you managed.
And what's your most important and free energy source that you have available in your racing? Because energy you're going to need, it's oxygen. It's the source of input to your, let's say, your journey from start to finish as well.
Can I ask you, metabolic testing in the field with a portable VO2 Master versus back in the day when you did kind of lab metabolic carts, what are some of the key insights you've learned that perhaps you wouldn't have picked up on?
I could pick a lot, but I would say the most important one is timing of intervals when you have multiple sessions a day, for example, and efficiency. Those are the 2 most important ones. Efficiency is a greatly underlooked and also misunderstood metric, or like undervalued and misunderstood, because very often when we hear VO2 max and we hear big numbers in elites, we think that higher is better. It's not. You want lower for the same target speed. And the reason for that is because it lowers heat production, which is an issue for people. It lowers basically metabolic demand for the person. So you are able to use your resources for a longer period at a higher output, or let's say a higher output. So efficiency is something that this is not new or innovative in any way, but is something that very few environments maybe utilize enough because they don't have access to a VO2 Master. And because of that, you don't necessarily understand. You just build your intervals and you see an athlete necessarily becomes better at their intervals, for example, training and whatever. So they run a little bit faster and so on. But you don't know whether is this costing now proportionally more or even disproportionately more than what you've done there. And basically, how quickly do my athlete adapt to that new type of interval or demand that you're putting them under? One of the best ways to understand a little bit, let's say, how mature you are for a certain type of interval is actually to assess the oxygen cost of those intervals. And the lower the oxygen cost is, the more mature you are for those kind of intervals, because you are more efficient, you have more practice, you're more experienced, the body have adapted to it in all kinds of aspects as well. And that's also when you can say that you are maybe ready to also do new kind of stimuluses as well.
So your efficiency metric then is oxygen consumption. You're looking at VO2.
Or VO2 relative to the output. If you look at it in terms of power, you would look at basically how is the VO2 to this power for this, let's say, or let's say accumulated for this kind of session. And the same thing if you're running and you're doing some kind of new intervals there as well. Again, you can of course use it for a full session, but again, this is a place where we normally we do it on some intervals, beginning, mid, end, depending on whether we find some intervals more interesting or not as well. And then you look at basically the oxygen cost for this, let's say, throughout session for an athlete. And typically what you'll see is the beginning of a season, when everything is a little bit fresh again, oxygen cost for athletes are actually higher for same type of intervals than it is later in the season, showing that basically your body maybe have lost a little bit of its efficiency and other things that are there. But this is basically also when you then go through the season and periodization, you have new type of intervals and this kind of thing. You'll also start to see that when you introduce new type of intervals or intensities, you are less efficient there compared to when you practice this for a while. And then you can also question yourself a little bit when you come to a certain point. Now there is no change anymore in efficiency for an athlete at this kind of interval. Do I then change it in order to provide a new stimulus for this athlete? But of course, leading into races, that's exactly what you want to see. You want to see oxygen cost coming down, down, down. And of course, this requires precision in what you do. But also when it comes to calibration, one thing that I think most people are not aware of, VO2 Master has to be calibrated. It has to be what we always do. I run these systems also on, since we use also metabolic carts sometimes in a laboratory setting as well, I have the highest interest in that these devices are more or less the same. And we use still actually our old system, which is still the gold standard, and that is our Oxycon Pro with mixing chamber. However, when we are and there's a couple of reasons for that, but you lose also some data with that when you use these kind of systems, because you don't get the breath to breath dynamics when you use a mixing chamber system. However, when we then look at efficiency, the reason why I want this to be the same is because I want to know that what I measure in the lab with this is the same out in the field. And that's also why we have third-party systems, which basically is what we call a metabolic calibrator or a metabolic lung simulator, almost like a metabolic simulator. And what we do with this is that we buy in huge bottles, which has a known concentration of oxygen and CO2 inside. We feed it into the system, and we also can control the ventilation, the tidal volume, and the breathing frequency of the system. And if the device doesn't measure within, let's say, very tight margin, what we are at, then we know there's something wrong with the metabolic analyzer. When we calibrate, for example, the VO2 Master, or even when I'm in the lab and I calibrate the metabolic carts as well, I normally calibrate in the beginning just because of a routine. Then I actually use the mask on the athletes during warm-up to warm up the device properly. And then immediately after, I take it off and I do a new calibration of
with the syringe.
Yes, forced one. I don't stop the session. I do forced. So I go back to the first screen and I press basically calibrate flow, calibrate gas for the device. And then afterwards there, we have what I would call gold standard repeatability.
Do you have, one piece of advice perhaps for coaches who are keen to get into metabolic testing and how they could implement that into their coaching practice?
Yes, I would say that in the beginning, of course, if you consider obviously now VO2 Master being a very affordable device compared to the old metabolic cars we had, the technology had become far more democratized. Of course, obviously there are also some cheaper devices on the market, but you want to strike the balance between accuracy and, let's say, portability. You don't want to use something where you can't necessarily rely on the measurements either. So I would say first is to really start just using the VO2 Master and get familiar with it. Getting really good, getting really good routines and procedures when it comes to calibration, ensuring fit on the face, making sure that you understand how to make sure that it's airtight, all this kind of thing that is there. And then in the beginning also, don't really use the numbers for too much. Just play around a little bit with the numbers in, let's say, in comparison with speed, velocity, and power, depending on whether you do swimming or running or cycling or whatever you do. As you start to collect more data, it's a little bit like if you, the first time you have a power meter and you start to collect power, okay, somebody goes out and they write 300 watts, whatever. Okay, what does that tell you? Nothing. You don't have any reference frame. You have no reference frame whatsoever. So this is why when you start to write a little bit, you will naturally start to see, oh, when he goes shorter, harder effort that he feels is hard, this is how high power he goes then. For the longer, it looks like this. And when he goes easy rise, it looks more like this. And then you also do the same with the VO2 Master. You actually start collecting data there. And I would say the future is actually in the field. To give some context to it, 30 years ago, 40 years ago, people had to go to a laboratory to do testing and to get power numbers for their athlete. However, did it have a value to coaches or people? No. Why? Because it was a number that you never saw otherwise than the one time you went into a laboratory and you saw a power number from a stationary ergometer that was there. The revolution came when the power meters became available to coaches and athletes in the field. That's what actually is happening now with metabolic analysis as well. Now we're getting portable metabolic analysis that actually, with the VO2 Master, we can bring it out in the field and we can start building the same understanding and the same curves of an athlete that we've never done before. And we have actually closed the circle of engineering because now quantify every step from output or basically input to output with our athletes with 3 key tools that gives us an idea of, okay, I want to improve efficiency, I want to improve power. That's why these three tools are basically a revolution. We got a revolution, let's say, in the tools to quantify and automate speed curves, power curve. Now we also have it for metabolic curves, and you don't need anything more. It's the end game, more or less, of really being able to think like a Formula One engineer for how to influence human efficiency or human performance.
That's brilliant. As you said, the versatility there for a coach to be able to use it in their exact context, which is different between coaches because everyone's working with completely different athletes and clients. And I like that you said it's not about like memorizing existing protocols either. It's have some familiarity with some of the key protocols like graded exercise tests, etc. But you can go out and actually just test in the field what the athlete actually does, collect that data, use it, understand the insights to inform the training, see what that does, how that influences the output, and so forth. Which is fun for a coach. That's what good coaches like. We were trying to constantly optimize, and I mean, you've got enough experience, but there seems to be no ends to how far we can go with this, right? With human performance.
But that's one thing just to be aware of there, just to be mindful about there. When people went from heart rate monitors to power meters, people got very confused because they were used to that when they started to go harder, there was a metric that started to go up slowly and adapted. So it was easy to just keep a track on the number. When people got a power meter and they say that they had it on 1 second averaging or even 3 second averaging, but let's say 1 second averaging, numbers was all over the place. And they're like, what is going on here? There must be something wrong with it. No, this is the nature. When you actually are pedaling or running or whatever, you will not pedal 300 watts. It will basically bounce all over the place. But as you get better, it will bounce less over the place, but still bounce around. When you are in a laboratory and if you have a mixing chamber system, things will be smoothed out. It's like you put 30-second averaging on your power meter. Why would you do that? When you have a power meter, the whole point with that, then you can just go by heart rate. You would, of course, almost, if you want to control intensity, you want to have the 1 second averaging because it gives you a better understanding of a lot of things when you start to see past the noise. Because noise is a lot of signal, but all that signal is perceived as noise. And that's the same thing also when you get a system like the VO2 Master that gives you instantaneous feedback on what's going on with your body. So if you swallow for a moment while you're running, and you start to see VO2 comes up and saying, no, this must be wrong. No, it's not. You created a small depth in your body. Now your body have to pay it back. All these kind of nuances in the beginning, it's so much signal that it's perceived as noise. And that's why give it time. get used to it, and you'll actually start to see there's a lot of signal here that you can start to break down and learn more from.
And that's why you want that second by second data, the granularity, to understand that.
Exactly.
That's brilliant. I'm very excited to start applying more of some Olav secrets. So thanks so much for your time, Olav. Really appreciate it. And I'm sure there's going to be a lot of value there for aspiring coaches to get into metabolic testing.